Magnitude of a magnetic field due to a current carrying wire. The symbol for the magnetic field is capital B. Magnetic field is a vector and has both magnitude and direction. The unit of magnetic field is the Tesla, where Teslas are newtons divided by amp meters. Because the Tesla is such a large magnitude, another unit is frequently used, the Gauss, where 1 Gauss is 10 to the negative 4th Tesla. To gain perspective, the magnetic field of the Earth at its surface is around 0.5 times 10 to the negative 4 Tesla, or simply 1/2 G. A current-carrying wire generates a circular magnetic field around it. The right-hand grip rule determines the direction of the magnetic field surrounding the wire. The magnitude of the magnetic field at a distance r away from the wire is given by this equation, which is on the AP2 equation sheet. The constant mu0 is called the permeability of free space, and it has this value. The permeability of free space, mu0, is a constant that relates the magnetic field produced by a current or a moving electric charge in a vacuum to the value of the current. It is a measure of the ability for a magnetic field to propagate through a vacuum. Permeability will have different values for different media. Did you notice that when you solve for B, using the equation on the previous page, you don't even have to use pi? The value of mu0 and the geometry of the problem enables us to cancel out pi. The constant mu0 is the magnetic equivalent of the electrical constant epsilon naught, which is the permittivity of free space. The physics aviary has a simulation that shows the magnetic field wrapping around a current-carrying wire. What is the magnitude of the magnetic field at a point 2 meters away from a wire carrying 500 amps of current? Here is our equation. We can see that the strength of the magnetic field is directly proportional to the amount of current going through the wire. So the more current, the stronger the field around the wire. And it's inversely proportional to the distance away from the wire. So if you double your distance away from the wire, your magnetic field strength gets cut in half. Let's plug in our numbers. So here is our constant for mu0 here, then 500 amps, 2 pi, and 2 meters. This pi is going to cancel out with that pi. Here we have 2 times 2, which is 4, which is going to cancel out with that 4. And then we get 500 times 10 to the negative 7th, which is 5 times 10 to the negative 5th Tesla.